3 books no matter what order you chose them in. So that might be an example of something that the order doesn't matter, whereas the ice cream example we keep bringing up, the order does matter. Okay, so combinations of n objects taken are at a time. So this, relating to this example here, would be a combination of 4 objects, the 4 books up here, taken 3 at a time, because you're selecting 3 books. All right, so the formula here, we've got very similar notation, except we use a C for combination instead of a P for permutation. So this formula, what we do is we take the number of permutations, which we write as n, and then a P, and then an R, and what we do is we divide out R factorial. So R is the number of objects that we chose. So in this example, if we take A, B, and D, we also could have done ADB, BAD, BDA, DAB, DBA, 6 different orders that don't matter at all. And so what we do is we take the total number of permutations and then we divide it by the number of ways that we could have rearranged those 3 objects. Because we don't care how many ways we can rearrange the objects, we just care about the total number of groups that we can get. So we would want to divide this by 6 because there are 6 multiples of each of these groups that don't make a difference. So we take the permutations and then divide out R factorial. So what that ends up being is n factorial and then divided by n minus R factorial times R factorial. So you'll notice that this part of the formula right here is the exact same formula that we've got up above, and then since we divide by R factorial, the R factorial ends up in the denominator. So this is the new formula that we're going to be using. So when you're looking at your homework in the book, you're either doing n permute R or n combination R. You've got 2 different formulas. Just keep them handy so you can use them. Okay, so flip over and we've got a couple more examples here. So a restaurant offers a total of 8 side dishes. How many different ways can a customer choose 3 side dishes, which would be a giant meal? So let's say, you've got your French fries, macaroni and cheese, baked potato, I don't know, whatever sides you can order with a meal. If you choose macaroni and cheese and a side salad and French fries, that's no different whatsoever than choosing a side salad, French fries, and macaroni and cheese. So this falls under the category of combination rather than permutation because the order that you're getting those things in does not matter at all. You still get 3 items once your meal comes out. Okay, so you've got 8 things to choose from, and you're doing a combination where you choose 3 items. So remember, this is the total that you're working with, and this is how many of them you're selecting. Okay, so we plug these things right into the formula. I'm going to write the formula up above again. So we've got n factorial divided by n minus R factorial times R factorial. Okay, so n factorial, n is 8, so we get 8 factorial in the numerator, divided by 8 minus 3 factorial, and then times 3 factorial. So 8 factorial, nothing's changing there. This is 5 factorial, because 8 minus 3 is 5, and then times 3 factorial. So again, you could just plug that whole thing into your calculator. I'm going to write it out so you can see where some of these numbers come from. So 8 factorial. Remember, factorial means you just start with the biggest number and then multiply your way all the way down to 1. Then 5 factorial. And then times 3 factorial. Okay, so you'll notice here, you've got 3's that cancel, 2's, 1's, then you can cancel these 5's, you can cancel these 4's, and then there's a couple things left over that you can cancel out as well. For example, 3 times 2 times 1 is 6. So this is really 6, so you can cancel that with the 6. And then all you've got left over that I haven't canceled out yet is 8 times 7. And so 8 times 7 ends up being 56. So there are 56 different ways that you could have chosen 3 side dishes. Okay? Big ticket idea here. How can you tell the difference between a permutation and a combination? I've said this a couple of times already. If the order matters, it's a permutation. Okay, so let's write if order matters, then you know it's going to be a permutation. if order does not matter, in other words, if the problem is done with no regard to order, then that means it's a combination. Okay, so our remaining examples here, we're just going to talk about whether something would be a permutation or a combination. So example 5, they're both based on this idea of 300 people buying a raffle ticket. And then when the raffle tickets are drawn, there's 5 different tickets drawn, and we've got 2 different possibilities for how the prizes are claimed. So in part A, you're choosing 5 people that each receive one of the following prizes. So the first raffle ticket drawn gets a keychain. The second raffle ticket drawn gets a mug. Third gets a t-shirt. Fourth gets a TV. And the 5th person drawn gets a new car. So in that sense, it does matter who's drawn first, who is drawn second, who is drawn third, etc. And so since it matters the order that these people are drawn in, that would be a permutation. So this example is going to be a permutation. And then for part B, choosing 5 people to each receive a t-shirt, it doesn't matter if you're getting the first t-shirt or the second t-shirt or the 5th t-shirt, you're still just one of 5 people that's getting a t-shirt, and it doesn't really matter what order they're drawn in, versus part A, where if you're drawn 5th, you get that new car, so you'd rather be drawn 5th than first. But for part B, it doesn't matter if you're drawn 1st, 2nd, 3rd, 4th, or 5th, you're getting the same prize. And so since there's no regard to the order whatsoever, that would be a combination. All right, so I'm going to make sure that this video is posted so that if you guys were, falling behind on anything, you can look at this, and your homework should be written on the board for you, and I'll also post it on Plus Portos. So sorry that I wasn't here today, guys, but hopefully you did well.